Well, welcome to a PSL demo day. I'm really thrilled to have with us today Matt McKay, who does work with QuantEcon as well as the Executable Books Project. We're going to hear about the Executable Books Project and the work Matt's done with MyST. Matt, take it away. Good to have you.
Thanks, Jason. It's good to be here. It will be a great opportunity just to share with what we've been working on the executable book side of things. So today's talk will really just be about. Sorry, I just forgot this slide. Just to introduce myself to this group. A bit of my background is I guess if you were going to give me a title, that's sort of an infrastructure and software development lead here at QuantEcon across a number of different software projects that we run. I work across a number of communities, including the Executable Books Project, but we also are running a couple other projects as well. And QuantEcon builds infrastructure that contributes to executable books in a sort of a two-way relationship. We build a lot of things that suit sort of economics and what we need to use or support. We've really enjoyed working with the executable books community. And QuantEcon was one of the original three groups that formed what is now Executable Books. My background, just to give you a bit of background, academic background, engineering, computer science in undergraduate, and then I did graduate studies in economics. And so I've got my research interests would be in computational development economics, and that's what my graduate studies was in. So just a quick summary of what I wanted to run through today. I wanted to introduce you to the Executable Books organization, what they do and who's a member of that group. A lot of the material I'm presenting today is a huge body of work from a lot of different people. So I think it's important just to acknowledge that. Then I wanted to spend time on what is MyST, what is MyST Markdown, and what benefits does it bring to the Markdown ecosystem. And then I'll talk about how do we actually render MyST. So there's currently the primary avenue up to quite recently has been JupyterBook. And that's kind of built around a Python software stack. But there's also a really fast development going on in this JavaScript space or MyST JS space. And that stack is coming along in leaps and bounds. And one of the really exciting things that's come out of that stack is, for example, a MyST extension for JupyterLab. So you can now render MyST, a lot of the MyST syntax natively in that JupyterLab straight away. And that gives you a really quick, we've been using it over the last 4 weeks here at QuantEcon, and we've really enjoyed using it because for new authors and new contributors, you really get access to what MyST might look like without having to go through a multi-step process of building, writing, building. So a lot of those tools are really coming down the pipeline. And so I'll give you some updates on that. And then I'll lastly just quickly run through how does QuantEcon and JupyterBook work? How do we use JupyterBook in our operations? Feel free to ask questions along the way. So the Executable Books Project really extends Jupyter's approach to open standards and building tools that are catering towards authoring, reading, and publishing these computational narratives that we all love in notebooks. Obviously, the source files don't have to be notebooks. We also have a text representation called MyST Markdown that we personally use a lot just because it really assists with the version controlling. But there's no reason you can't also use notebooks as source files, and we'll go through that when we talk about the build system. So the Executable Books organization, you can find out a bit more information at executablebooks.org, who's part of the team and what they do. But really, this sort of virtual organization are the stewards of JupyterBook and also the MyST ecosystem. So we're talking like the MyST specification. And the team listed here across these various organizations have done all the heavy lifting, and we're a part of that team over here on the right. But all these guys do a lot of work on getting these projects moving forward. That's what I'll cover here today. So MyST stands for markedly structured text. It's heavily inspired. I don't know if you guys have used restructured text. It's heavily inspired by a few things we learned from that project. but it's really, and then ported over to the Markdown domain. So it's really a rich and extensible flavor of Markdown that's meant for writing scientific documents and technical documentation that has a build system that caters towards high quality publishing. There's a website here called MyST.tools that you can go to, and that's sort of a collection, a high-level collection website of all the various tools that go into supporting the MyST ecosystem. So that's a really good place to start if you're learning about MyST and what tools are available for it. So MyST really, Markdown aims to be, oops, trying to get something out of the way here. It really aims to be that cross-platform, extensible, open Markdown standard designed specifically for scientific and technical communication. So really what it is it's a superset of what's called Common Markdown, which is a Common Mark standard, controlled very tightly by a specification. Most parsers of Common Mark should render fairly similarly. So it's a superset of Common Mark, but we add extra syntax that really gives Markdown superpowers, is how I'd best describe it. And the ideas of directives and roles is really the extension to Markdown that really allows users to define functionality and new behavior that extends Markdown into new domains. And we'll talk about what those objects really are, but that's essentially one of the key extensions to what MyST brings to Markdown. So how is it useful? Well, MyST can be, can you see my mouse, by the way, or is that invisible?
Yeah, we can see it.
Okay, great. So MyST over here it can be represented as a text file. It could also be a notebook. And the syntax is really very similar to Markdown. I think if you've used Markdown before, you'll know Markdown links, you'll know section titles for H1, H2 headings. What you might not have seen before are these roles. So this role is like an inline markup to Markdown, which operates on some content. In this case, this is an index role that sort of marks a location in the document where you want to build a full document index at the end of your project, maybe in your PDF output to a whole bunch of pages throughout your document. And this is just a placeholder to say, hey, I want an index put on this page, an index entry put on this page under this title. So that's a function that takes up a really small amount of space that uses its positional information and acts at a document level for building an overall index in the end of the day. So that's what's called an inline role. That's just one example. Citations are another good example of roles. And then directives here are multi-line functions that act on content or do some work behind the scene from the build and rendering system. In this case, that will build a small mini table of contents at the top of that page for you. So that's really the two extensions. There's obviously support for scientific markup like math. And the other cool thing is the other really key part of MyST is that it brings in code execution as a first-class native citizen. And so it takes all these, and we do that through this use of directives, essentially. So there's a directive called code cell. You link it to a Python kernel. We're using the Jupyter infrastructure behind the scenes to connect that code into a Jupyter kernel, execute, and then come back with the results that we can then spit out in the rendered output. It also, these projects and renderers also bring support for large document attributes, things like cross-references, footnotes, margin notes, math, citations. Math is part of Markdown, but a lot of these other infrastructure stuff is Markdown's wasn't historically catering towards large multi-page documents. So when you go through the build process through some form of a renderer, in our case, there's two available, Jupyter Book and MyST JS, you end up obviously with a rich website output in the form of HTML. But you can also output other parts through using extensions. So in the QuantEcon case, we output notebooks that we then use, that users can download locally, or they can attach from our lectures using those notebook form up into the cloud in Colab or Binder to have a full version of that lecture that's got backed by an actual computational kernel, so they can start playing around with some of the elements in the pages. Things just coming down the pipeline that I'll cover off is that there's a really cool project called Thebe and SphinxDB that's trying to sort of bring that execution closer to the actual web experience, so you can start interacting with some of that stuff in the actual website rather than having to dispatch out to a separate service. There's a lot of people interested in that. But obviously these directives then get morphed into what they get treated as special content, essentially, and get processed by the rendering system and outputted as rich objects. There's obviously this, in Jupyter Book, there's automatic numbering, talk generation, all those things that you don't have to handle when you're writing your documents, which is really nice. And obviously it embeds, there's an execution layer. There's also a caching layer so that in Jupyter Book, so that you don't have to rerun your project every time. And it will only recompute things in code cells if they change on a page. So, and then those results, once computed, will be saved in the Jupyter cache and can be used for future builds. And those rich, nice outputs are included in your documents. So directives, just taking a step back, what are they? They're really functions for blocks of Markdown. They follow this standard syntax, 3 ticks, the name of the directive. So here it could be math to describe, you've got math content. We try really hard with the MyST specification to bring the naming conventions close to how you think of things as you're writing from an authoring perspective. I think my best description of MyST to someone the other day was when you first pick up Python. How many of you are Python programmers? I experienced when I first picked up Python, I was like, the difference between this language and all the other ones is that I can actually just start typing and I can remember the syntax, and it's highly productive, right? So I think MyST is kind of a similar experience for me when I went from restructured text, which was great and wonderful. We used it a lot in our Sphinx days when we built our websites using Sphinx directly. There's less white space issues, for example, that you have to sort of mess around with. There's just less overhead in thinking with these gated directive syntax that's been introduced. So essentially, you come up with a directive that does some action on a block of content. There can be positional arguments. So for example, if you have an admonition, you can have a custom title that will get imported into your object. And then you can have options to control that behavior. So you can theme it with, give it a class warning, and it will be, if your theme supports warning admonitions or note admonition styles and stuff like that, it will carry through to the HTML, and that metadata essentially that's attached to that content can be acted on. So here's just some examples. So for example, admonitions with a custom title in Jupyter Book. If you attach a class warning, it will look like that to the right, and this is the content of the message. It does support nested Markdown. So everything you do can be nested inside of these admonition blocks. They get parsed as well in a sort of recursive nature. Figure is obviously bringing in figures. You can apply names so that you can reference those figures throughout your documents. You can provide captions. You can change the size of them. You can do lots of things, change the placement and things like that. And then there's some other sort of structural features like tab set, where you can bring in some new kind of cool objects into your documents that give you multi-tabbed previews of something. And that can be really handy if you're talking about like Python and Julia and other languages, and you want to have an example that spreads across the same content, but in different representations, for example. So having these dynamic, the ability to have a huge amount of flexibility in taking some content and converting them into these sort of new and novel structures is a really powerful concept. And it's really only limited in the Jupyter book case. It's built on Sphinx, right? So it's actually really extensible. So it's anyone in theory can go and write their own directive and role and change the behavior or something and bring it into a project. So it's it's kind of unbounded through the extensibility of being able to act on these directives and roles. A role is really just the same thing, but just for inline markup. And they have different use cases. So for example, here you might want to just have cite and then a directive to a BibDeck key, and that will just automatically place a cite role. For example, here you got a cite to a BibDeck key, and that just brings it in the citation syntax that we're all familiar with this in this sort of publishing. You can do formatting roles to change what text looks like. You can bring in favicons and references, which are more of the common use cases, cross-thinking. So that's essentially what MyST does. It extends common marking to this domain of functions through directives and roles. So how do we actually render this MyST syntax and these extensions? Well, there's currently two primary avenues. There's just Jupyter Book. Its sole ambition is to build beautiful publication quality documents that enables computational material. I think it sounds like you guys have used Jupyter Book already. So maybe I can change this presentation a bit to be a bit more useful to you. So let me know if you want me to focus on something else, and I'm happy to talk about it. I'll just skip through here.
Can I just ask a question, I guess?
Yeah.
So at some point, months ago, maybe a year ago or more, I was trying to use Jupyter Book to basically do blogging, and I contacted one of the leads and they said that was cool, but it's not really built for that yet. And that was sort of evident in some of the things. What you just showed in terms of MyST makes me wonder, like, can you have folks put MyST and Jekyll together for blogging? And like, is that a more mature use case now, or is it still better off just with Jekyll by itself or something?
Yeah, good question. So Jupyter Book in particular it was really built with the ambition to build books. It's designed, it obviously uses Sphinx under the hood, so there's absolutely no reason it couldn't be used as a blogging platform. It's just not. So for example, the talk structure, we tried to make it really easy for people to use two primary talk structures with Sphinx. Through the talk.yaml. So you can specify sort of a chapter part, like a simple document with just chapters, or parts where you can have multi-part things. So that interface, it's really an interface issue to an extent to use Jupyter Book directly as a blogging platform. So yeah, so it's basically a use case issue, not a capacity issue, if that makes sense.
Yeah, I guess specifically, for example, we use Jekyll for one of my nonprofits, which is basically a think tank that does economic policy simulations, and it's in a blogging style framework. Like, could we put MyST into that, or?
Yeah, I mean, you mean, can you put MyST into Jekyll?
Yeah.
No, not yet.
Okay.
So there's some things coming down the pipeline. So I'll talk briefly about MyST JS right after this, which is sort of an update on that aspect. And I think that's bringing essentially Jupyter Book to a JavaScript-based project that is closer to the web environment for native rendering of MyST syntax. So those sorts of projects are really making it quite feasible to sort of get that idea of, hey, I want to add here's some syntax, and then here's a JavaScript thing that will render it. And that's getting a lot more possible and feasible. I'll take it as an issue. It's a really good question. I'm not into the blogging side too much, but I will get the state. I'll go and find out the state of the union on blogging support from the CurveNote team and the MyST JS team. They do a lot of work in that space, and I'll send you an email.
Thank you.
With an update. But essentially, Jupyter is set up primarily with that idea of building a book, chapters, to make it super easy, primarily for authors to build books. And that's what it's really set up to do. So I think we all know it can take text, make notebooks, it adds execution, but it uses Sphinx. But what is Jupyter in reality? It's really a top-level CLI tool that really brings together a huge amount of modular tools and a huge amount of development under the hood. So Jupyter is a really good place. Jupyterbook.org is a really good place to start if you're wanting to learn what it can do. It's kind of a website that focuses on the authoring experience. But keep in mind that it's built on a whole bunch of tools under the hood, which includes MyST Parser, MyST and then things like Sphinx Book Theme. And we stitch all these modular components together to deliver the CLI, top-level CLI tool. MyST Parser is really sort of what historically has been the project that's defined MyST and how it gets rendered. And you can actually use MyST Parser and MyST straight with Sphinx. You don't have to use, technically, you don't have to use Jupyter to actually do your building. We do, because it just makes life easy. But all of these are extensions built on top of Sphinx. And then the book theme is sort of a theme that gets applied to the Jupyter book. Through the Sphinx sort of infrastructure and plumbing. So this project can be really useful. It's got great documentation. It can be really useful for looking at some of the more advanced features coming down the pipeline. Like there's some new features that have just been released looking at inline evaluation. So you can sort of take variables from some code environments and then have them represented in your text that's automatically updated in LINQ. Lots of really cool features like that. The Jupyter Book CLI, we're getting a bit better at bringing in all the improvements made under the hood. We just released last week Jupyter Book 0.14, which is a really big update. It includes a lot of updates from MyST Parser and MyST. So definitely worth checking out Jupyter Book 0.14. It's also got a lot of quality of life improvements. Things like the execution failure output is better and more aligned with the source material and things like that, which is really handy. So that's what Jupyter Book is a compilation of modular projects underneath the hood to make it really easy to use, hopefully, for authors. We're always keen to get feedback. Okay. So as you know, they build books. The focus point of the whole executable projects has been on computation-centric publishing. It's a really killer feature, killer aspect of the project and what it offers. This is just an example, like saving a plot via glue and then inserting that plot later on in your text with some ability to, alter formatting and linking it with references and things like that you'd expect to be able to do. So that's really a mantra for the whole Executable Books project, given that it's even in the name. So computation-centric publishing is key, but it also has support for these really nice interactivity features, things like drop downs in your text, things that let you sort of change some state, and inclusion of these sort of really nice, more modern objects like Plotly objects and things like that. I will just say with one caveat, if you look through, for example, in the QuantEcon lectures, we'll at the moment, we don't include some of these sorts of objects primarily because we're wanting to retain support for people who want to interact with our project via the PDF. So there's this interesting tension between the dynamic HTML output and the static context for PDFs. And we're currently working in the background to sort of think about how do we resolve that, because these sorts of features are beautiful and really useful. But so, for example, the thinking at the moment is for any like really rich dynamic content, we're coming to the conclusion that most people will have a hosted HTML version of whatever they're publishing. In the PDF, we'll likely try and work out a sensible default static representation along with an automatic link to wherever you're hosting your content, to bring that into a space where that dynamic content makes sense and can be acted on. So MyST JS, I don't know why there you go, MyST JS. You can see it has kind of the same description, right? So I did that on purpose to say that there's two sort of parallel projects at play here. JupyterBook came from a book perspective, where Sphinx provided a heap of the book style interlinking document plumbing that we could build upon to build these really cool, beautiful books. MyST JS has evolved from more of an article perspective, single page documents, but is growing quite rapidly into sort of an alternative for the multi-page document case, and rendering state between pages and managing all that complexity in a JavaScript stack. And the team's done really good work on this. I'm a Python person, so my input into this side of the project is more testing, but I'm really excited about it. And executable books, now a lot of people, I just wanted to cover it briefly because a lot of people go, well, why are there two sort of software routes and platforms at the moment? Well, they offer this pros and cons to both, essentially. And having a JavaScript stack that's really sort of more native web environments offers things that you couldn't get in the previous implementation. And so Executable Books is realizing that MyST is bigger than the parser, right? So MyST, the strategy is Executable Books will focus on the MyST specification and what elements should do in general, and then let the parser space adapt and change and evolve. And just a key example is what's growing out of this MyST JS, which is really exciting, is the JupyterLab MyST extension that's getting updated at the moment on weekly or bi-weekly pace. But it's really fun because it's a really neat way to get in and have a look at what MyST can do in the notebook level without going through a write, eval, publish step. I will just throw in the caveat that they're not exactly the same. So, for example, JupyterBook is what I would call probably more stable and more feature complete. There's things like Sphinx exercise for writing exercises in your documents, Sphinx proof, and lots of different extensions in that space that can be really useful for writing that obviously haven't been moved over to the MyST JS space yet. So we're in that period where they're not one for one. So just be aware of that when you're starting to play with or think about using these things. But it's evolving really quickly and really rapidly, and it's really useful. So MyST JS, which is the power behind JupyterLab MyST extension, renders a lot of the stuff. It renders almost most of the core MyST spec. It just doesn't render a lot of the extensions that are available in JupyterBook, essentially. And so we've actually in QuantEcon switched over our whole workflows in the last 4 weeks to embrace JupyterLab MyST as a primary writing tool. Particularly when we're working with new people who have never used MyST before, it's really handy being able to write something straight away in admission or to see how it works, Control Enter, and you get to see it rendered in the notebook. It's really handy. JupyText is beautiful because they just updated JupyterLab MyST to leverage the JupyText mirroring representations of data. So you can actually now open, if you use MD files because you like them in source control, for example, you can actually open MD files directly and they'll automatically go through the JupyText layer into the IPython notebook. You can edit it and it will save it back into the markdown layer without you having to create multiple files or multiple representations, which is really handy. So we use JupyText a lot just to define very early on part of the project, we really wanted to make sure that the text representation was a first class a one-to-one mapping with the notebook format so that we could enable that two-way dialogue between those two formats really easily. And that's an outcome of that is that project keeps those formats in sync, which is really kind of a neat tool. So yeah, so it's a very similar structured concept to Sphinx. It's just written in JavaScript. So it ingests these source materials, it puts it into an abstract syntax tree representation, or what they've called structured content. And then they use different modules to spit it out into websites, journals, PDF, Word, LaTeX, and things like that. I know that I have to dig into this a bit more, but they've put that team has put a lot of effort into making readable LaTeX, which is kind of different to what gets outputted by the Sphinx LaTeX writer. Sphinx LaTeX writer has a lot of sort of pigment markup, for example, that makes it really hard to edit. So you're kind of constrained to source and then PDF, and then you have to sort of work with the internals to get it to maybe a format that you really want at the end of the day. Whereas there's been a lot of effort in this next iteration to think about, well, what if people want LaTeX rather than an intermediate format, but an end user format, so that you can then get 90 or 95 or 98% of the way towards your final publication from MyST, and then you can tweak it. So there's lots of those things coming down the pipeline. But essentially it's structured very similar to how Sphinx works for the Python side of the project. Ways to try out this MyST. So if you can click on MyST Tools, or there's the Jupyter Book Quick Start. Jupyter Quick Start builds you a project or a book project that you can run with. MyST Tools is just sort of an online MyST JS representation where you can change the left field and just play around with what these things do over here. Okay.
Now that's interesting, Matt. And just so like that kind of preview like that is something that's very nice to have in your text editor, and you can do with Markdown. Can you do that with, or are there extensions for like a VS Code or other text editor to have a preview of the MyST, so you can kind of live as you type see what, just as you did in that web demo?
Yeah, so that's definitely coming. I know there's a huge interest in VS Code extensions. There's a VS Code MyST syntax highlighter, which doesn't render it, but it does works on an LSP to give you all the new beautiful highlighting, and that gets you a fair way because it shows you where your syntax is broken. But that's one of the reasons I'm really excited about Jupyter Lab MyST is you basically get that rendering in that context, and then that's going to be that project will. I know there's a lot of interest in bringing that over to like a VS Code extension. I don't think it's there yet. I certainly haven't used it if it exists, but if it exists, it'd be pretty new. But I'll check on where that's up to and get back to you on that, Jason.
I have a question about MyST. It sounds like, am I interpreting right that you can make your own directives or okay? Can you give an like how folks have done that beyond, because I think I'd only seen the core ones, like the ones you displayed.
Yeah, so I mean, let me just my window just so I can see what I'm typing here. So for example, sorry. Executable books. Let's go Sphinx exercise. Here is an example of this is an extension that isn't part of Jupyter Lab. Jupyter Book, but it is something you can just go into your. Pull this page down a little. QuantEcon, Python MyST. You can go into your config files and sort of just add to the so you can configure Sphinx through the config top level config file, and you can add some extra extensions, for example. So here we go and add in Sphinx exercise to give it extra capacities. And what that extension does is it teaches it how to interpret a block of text, well, a directive called an exercise directive. So here, if the MyST parser is happily to ingest unknown directives, and then it leaves it up to Sphinx to connect it in the abstract syntax tree parser, and it connects it in that Sphinx extension essentially teaches Sphinx how to recognize and what to do with an exercise node. And what that will do is render it in a nice little exercise admonition and supports linking to solution boxes, and your solution boxes can collapse. So let me just go Python, go to one of our linear algebra lectures, exercises. So then in your actual document, they get numbered as their own sequence of exercises. And then you can have sort of drop-down solutions that are linked to the actual exercises, so you can put them anywhere you want and keep them connected and all that sort of stuff. So that's an example of what's not a core Jupyter book directive, but it's written as a Sphinx extension that you can then just add to your config to enable that just through a simple, adding it as an extension to teach it how to interpret a certain directive or a role. Does that answer? I mean,
yeah, that's awesome.
There's a whole bunch of wrappers there's a whole bunch to learn about the Sphinx ecosystem when writing the Sphinx. Like, so the setup time is really learning how to connect into Sphinx and how to interpret the AST, so the abstract syntax tree, and how to think about Sphinx's processing stages. So Sphinx has 4 processing stages. One is like pre-parse, one is building the tree and then transforms on that tree and then post-transforms. So it's got different stages on where you can write and inject your code into to do some work. So that's the art of writing an extension for Sphinx, but there's definitely a bit of documentation out there, particularly on the Sphinx project, about how to connect those together. But if you wanted to ever write an extension, I'd be happy to link up with you and give you some pointers if you wanted some custom directives. But it's definitely feasible. I mean, it's unlimited to what you can do, really, just by how much you want to put into it in terms of time.
I think.
And then the only other element,
yeah, thanks.
The only other element I'd say is that sometimes you'll need support. Sometimes you need support in the theme to make it look the way you want it to look. That's the only other sort of piece of that puzzle. But you can inject CSS actually from your extension into that theme so that you can support the themed elements from your extension as well. So you just need to think about CSS and the cascading CSS interpretations of formatting to prevent some collisions down the road. But cool. So this is really the summary of the State of the Union between those two. It causes a little bit of confusion at the moment that there are 2 stacks. So I just wanted to sort of talk about why they exist and sort of some of the pros and cons between both of them. They're both really useful. And we use both of them in QuantEcon through the JupyterLab MyST extension. But all of our operations are built using JupyterBook. I won't go through this. I can leave this for you to go through, but this was really just how we use JupyterBook, how we use JupyterLab as a mixed with JupyterBook and JupyText. This is a standard sort of QuantEcon authoring workflow, and how it gets us over to publishing our material, which is fully automated through GitHub. We've developed a whole bunch of GitHub sort of actions to do previews, code testing, deployments to GitHub pages and the like. We've just recently built in sort of some lightweight. There's a cool project called CML, continuous machine learning, that we're using to sort of bring in access for some of our lectures that need GPU support, because we're trying to sort of push the barrier in our lectures with using JAX, and JAX runs really fast on GPUs. So we needed an environment where we can actually run GPUs for building the lectures and all that sort of stuff. So that's really fun. It's really exciting. The QuantEcon lectures have content in that really push that computational frontier forward, which is really fun. Yeah, and then I know it's 8:45, so this is sort of the end of the time slot, but just I'll leave you guys with this sort of list of resources. It's that you can certainly go through, but I'm also happy to answer any questions if you have any.
Yeah, well, first, Matt, this has been great. Thank you so much for sharing this and giving us the lay of the land with respect to this ecosystem. I know Max and I here are both users, and it's been such a powerful tool for us for kind of documenting our models. Myself as an academic, I feel like this is really where journal publishing ought to be going. I mean, we have obviously a crisis of like replication and replicability, and this would be the ultimate solution to that, is where every reader can go through the code and recreate the results in a publication. I guess
we all share that vision.
So that, and I guess in that regard, do you have you tried to broach that topic with academic publishers, for instance, and is there any traction there?
Yeah, there's been a lot of talk about that. I mean, I haven't been personally directly involved, but a couple of the team members have gone to a new initiative called Notebooks Now, which is really about that article publishing avenue. So there's definitely there's a big push towards the articles publishing, support for the whole publishing pipeline, for empowering it by MyST. So there's a huge effort underway in that space, and a lot of, I mean, CurveNote's putting a lot of work into article support through their platform, and yeah, there's a lot of work, and I know Rowan and a couple other guys are really focused on integrating with that community that's pushing that article publishing space.
Mm-hmm.
I'll try and get a better answer for you, Jason, on that, because I'm just not directly involved in that effort.
Well, I'm just glad to hear there are those efforts. That's really
it's
really positive.
There's a lot going on across the board. So there's a lot of moving parts, but there's a lot of exciting things going on, and the momentum's building.
Okay. Now, you had that example kind of QuantEcon workflow, which seemed like it started with a .ipynb file, and then went from there. But you suggested kind of at the outset, like one real advantage of just writing straight in MyST, where you can have that code cell directive for your code blocks, is that it's version controllable. Like you can see what the diff is from one commit to another. So tell me about kind of your thoughts there in terms of how this workflow example goes.
Yeah, so basically this is quite new, this workflow. I mean, previously we just sort of worked in a notebook and then played around in that space, and then we'd just start the real writing in a MyST markdown file. And then we would just iterate using JupyterBook to build it locally and have a look at the results and iterate that way. The reason we use most markdown files is because in Git, obviously being a text format, it's a lot easier to diff, and a lot easier to do code review, to do lecture reviews essentially, in the GitHub space. So until JupyterLab came with JupyterLab MyST support, which just makes it really nice and convenient to sort of get instantaneous results, we've just added that step in to allow us to play in that space, but we always typically convert those notebooks into a MyST markdown file, and then that's the resting state of all our lectures. So and honestly, with JupyText, the markdown representation, and the only difference between markdown and JupyterBook is that the text representation obviously can't save the executed outputs. That's essentially the leading difference between them. But essentially, from a structure perspective and in the input source perspective, it is one-to-one. Essentially, once you use GPText to convert between the two, so you can flip back and forth essentially between the two things. So all our resting points we use are just GitHub's rendering it, but are the plain sort of missed markdown files. And the reason behind that is that it just makes, I don't know, let's have a look at this. Just makes the diffs, I haven't even looked at this, but makes the diffs a lot easier to process. So here,
human readable. Yeah.
Process. Yeah, exactly. I mean, I know there's a fair bit of work in teaching Git how to do diffs for notebooks. Like, so it's technically, you can definitely do it. We like keeping things simple at QuantEcon, and having these direct diffs is just a lot easier to manage.
Yeah. Now, I guess in that regard, like tell me if this is way off base, but I kind of see like as MyST JS develops, you can kind of cut out at least what the conversion step 3 here, right? You could just write in your MyST markdown in your MD file, you have the preview going through MyST JS in your text editor. So you can see the notebook, you can execute the executable cells in that preview. And so no need to write the IP, write the notebook file, convert it to MyST. You could just do everything in real time in that MyST markdown file. Does that seem like a potential future?
Yeah. I mean, that's the same thing as putting GPText and the Sphinx build process on a change loop. I mean, you could in theory do that as well and produce sort of automatic outputs. One of the nice things about the MyST JS project, though, is exactly, you're right. It brings that sort of native web environment to be able to do those things a lot more easily, as I understand it, and being able to edit and get an instantaneous output is going to be really nice aspect of that environment space. But yeah, so I think it's definitely evolving towards, I mean, being able to do previews in VS Code would be really nice in that space.
Yeah, that has been one of the challenges, right, in writing like Jupyter books, is that I've got to write my code and then go compile everything to see what it looks like.
Right.
And then I got, if it doesn't compile, figure out where that error was. And, that can be, depending, sometimes time consuming.
Definitely.
And so to get that working with a live preview would be really, really, really slick.
Yeah, but I completely agree. I mean, that's basically available now, that sort of live preview infrastructure for the core MyST spec. I know the MyST JS team, we're starting to launch a project and thinking about how do we write extensions like Sphinx exercise for the MyST JS ecosystem, so that we can have elements that other people can write and change behavior of those directives and roles without having it as a core part of the MyST JS library. So that's getting worked on at the moment, and we're going to try, and one of the things we're going to be doing over the next 4 to 6 months is getting some resources here at ANU to build Sphinx exercise for MyST JS, and that would be a really fun way of exploring how do we introduce extensions into that ecosystem. But the live rendering of the basic MyST syntax is definitely available on the MyST JS space, and in theory, it's, I think, basically thinking, if you have that document as data, the MyST JS team are really thinking about it, documents as data, right? So you have this representation, and then you have that layer on top of it that just changes the look of whatever's underneath and controls that execution component and all that sort of stuff. In theory, you could potentially, I don't know, point the JavaScript renderer over just a GitHub repository of files. But one of the things to keep in mind is, as soon as you get into sort of multi-document sort of format like books, one of the things you need to parse is the state between those links of pages, and it's a lot easier to render a single individual self-contained non-linked page relative to being able to reach out and change states across collections of documents that then resolve cross-references and things like that.
Mm-hmm.
So yeah, so that's where that space will grow into for sure. And they're doing really cool things like the Jupyter Lab MyST extension. I don't know, when you're using Jupyter, you don't have any concept really of state. So you just have markdown cells. They have no relationship to each other. What Jupyter Lab MyST does really essentially is introduce that notion of state so that you can, and cross-references. So there is relationships then between the different markdown cells, and you can reference equations between those cells, and and you get consistent numbering across those different cells down the notebook format. So the introduction of state is really what allows a lot of those more advanced linking features, cross-references, and things like that. Equation numbering, a lot of those really nice automatic features that we need really to be productive.
Mm-hmm.
Because yeah, so automatic equation numbering is one of the cool parts of that Jupyter Lab MyST, whereas previously a lot of people were putting sort of flash tags in their equations and then manually matching the numbers and then putting markdown links between the two, so there's some nice convenience features coming down the line with that MyST JS project. Another little key example, I mean, this is available in both Jupyter Book and MyST JS, is that if you hover over a linked equation, it'll actually then show you a pop-up of the equation without having to navigate to it in the document. There's some really nice things coming down through like that. If you hover over like a Wikipedia link, it'll actually give you a preview of that page in place rather than having to leave your document. So there's a lot of interesting work going in that space to keep you in that space, but link you out to the multidimensional aspects of, research and writing.
Any other questions from the audience?
Can I throw one question in for Matt? I'm back, Matt. I saw that there was a Jupyter conference recently. So it's not the one coming up in May in Paris, but it was another one. I forget where it was. I was wondering if you were at a recent Jupyter conference and if you saw any other interesting things at that conference that are coming down that you didn't.
Are you talking about sort of the Jupyter configuration? There's some talk about bringing supporting some MyST features in Jupyter, but I was not at that conference.
Okay.
I actually don't have a good update for you from that conference. I've seen a few things on Slack channel, but I haven't fully absorbed what's happened in that recent conference. Did you hear of anything? Did you want confirmation of some cool new feature that's coming down the pipeline?
No, somebody tweeted a photo and I was like, oh man, I wish so badly I could see what they were working on. It's just, this project is extremely meaningful to us, and the Jupyter book and MyST, and it's just such a jump forward for the way we document and allow people to use these models. I just love it.
Awesome. That's great. Is there anything missing while I have you here that you guys would really want? I'm just curious.
So there's some LaTeX functionality of linking. Sometimes if you want to tag an equation and have it be referenced, so the command in LaTeX is /tag, and what it does is it shows the reference again without counting it as a new equation. You don't have to relabel it. It's for in books if you're showing another equation a second time, but you just want to use the same number it was first referenced as.
Okay. So you want two display equations with the same equation number.
Yeah. So there's just little stuff like that of kind of the broader functionality of LaTeX. But I almost feel guilty even requesting that, just because the functionality is so good right now.
It's great to hear I'm genuinely interested in knowing what this community wants or is interested in. I'm certainly not going to promise we can develop it straight away or even on the medium term, but I'd just be really interested in knowing if there's gaps, because that's useful feedback for us as we develop the MIST specification and we take different input from different domains and end users from different domains, because it's a cross-domain platform, but each domain sometimes has specific requirements.
Another one I haven't looked at for about 6 months, but we'd run into occasionally is just numbering sections and subsections. Like sometimes in a book, you'll have section Roman numeral capital I, 2, and then you'd have different section numbers under each of those and different rules as to when those section numbers reset.
That is limited. It's currently, you take what you get at the moment, and that's I know what you're talking about. That is something that we would love to improve in QuantEcon as well. That LaTeX provides beautiful flexibility in that domain, right? Like you can just start a new section, reset the numbering, all that sort of powerful stuff. But currently, so we use this thing called Sphinx multi-top numbering package under the hood, and we take Sphinxes itself is really kind of this built around this notion of hierarchical talk linking, and Jupyter Book sort of imposes a way to parse that makes it more meaningful to authors for books in terms of chapter listings or parts and chapters, and to introduce that sort of numbering that you'd kind of expect in a book-like experience. But it doesn't let you do that resetting at the moment. It's certainly something we could improve. I mean, for example, appendices, there's no real support for putting appendix A, B, C, D rather than section numbers, right?
I think that's right. I think we've just titled our appendices as section numbers. But I guess it must be really hard to incorporate the full LaTeX engine into executable books.
Well, that's right. So LaTeX is so flexible that there's a lot of discussion around how do you bring some of those LaTeX style features and in a meaningful way into the MIST language. A lot of that time it's really through those directives and options specifications. But I want to dive a little bit into the MyST JS side of things as well. They've written a LaTeX parser that takes the MIST same sources as the Sphinx projects, but outputs a lot more human readable LaTeX. So there's kind of a closer mapping in that implementation between what you think about in LaTeX and what you think about in MIST. So that could be a really useful domain to try and think about how we map some of those more advanced LaTeX features through to the MIST, underlying MIST, to carry that forward. At the same time, we don't want to pollute MIST too much. I mean, directives and roles gives us the flexibility to change a lot of that stuff through metadata. But you also don't want to, at the same time, you want to keep the syntax super concise and clean with the ability to operate on that metadata. So thinking about, that's what I like about the directives and roles, is you're really attaching metadata to content rather than forcing it into the syntax, so to speak.
Yeah, well, I do feel guilty even bringing up those things just because the rest of the functionality is so good.
Great, I'm glad. I mean, one thing that's really cool in the new release, Jupyter Book 0.14, is there's been a huge amount of improvements by the team in MIST Parser and MIST NB, and it's a big jump. It's actually, I think it goes across, it was a long time coming getting that release out, but it basically bridges 3 major updates from MIST Parser. And so as part of that, for example, I'll just highlight one thing, is that there's a much better support now for if you want to use a code-generated figure as a figure somewhere else in your document. That's certainly a possibility now. You could do it with glue, but now this is a new way of, I was trying to I'll try and send some links, but there's some nice ways. We're actually just experimenting with QuantEcon and taking figures that are generated by code, and then you can hide that code. And either you can completely hide it, or you can have it as a drop-down code cell or that sort of thing. So now you can have sort of code-driven plots that update and are contextual. And then you can
That's
reuse those
fantastic.
elements in other parts of the document. So there's a lot of really cool new things. I'm going to try and write a blog post about JupyterBook 0.14. We've got a migration guide out there just for your existing projects. So if you go to jupyterbook.org, we've just written this migrating to JupyterBook 0.14. That's just to alleviate a few of the pain points. There are some breaking changes, particularly in how options are specified in the config file. I mean, if you upgrade, you will get immediately probably a couple warnings, but those warnings will document about what keys you need to change in your config file, for example. They're quite nicely outputted. But this document, just if you get stuck, have a look here, just because it gives you examples of some of the key changes we found at QuantEcon, and a couple of other people have found as well in that migration update. Just some key things that have changed, and like for example, if you're setting your own notebook rendering priority for the different MIME types that are outputted in Jupyter's system, it's just the format's changed to be a bit different. MyST NB, now a lot of the options previously, execution timeout was more of a global parameter, but we're trying to align the where the point of action occurs to the options. So MyST NB is a new key that's just basically, this is a pass through to the MyST NB layer that controls the execution. You can specify an execution timeout and things like that. So it's really just about some of the updates in metadata and some of the keys. And then there's been some changes to Glue. So if you use Glue, do you use Glue?
Yeah, we have. It hasn't always been the easiest, I have to say, for me to use, but we've definitely used it and do use it. Yeah.
So one of the key changes to Glue is that it doesn't work on the global set of keys. If you want to do inter-document, the basic thing that's changed, it's now more robust implementation, but it says changed so that if you want to reference a Glue object in another document, you have to specify the doc that it's in. There's just a few things like that have shifted around. And there's currently a few limitations in shifting paths and figures between documents, but within documents, it works really nicely. And it's been improved a lot.
That's great.
Yeah. So I might write a Jupyter book, a blog post about some sort of new features that have come out in 0.14. They're obviously also documented on, you can go digging through MissParser and see what's available there if you want. But we'll try and do a series of, this is some of the new things that are available. And I'll copy you guys in on that. I'll send it to Jason.
That's great. Matt, thank you again. This has been wonderful.
No worries. Good to chat, and great to link up with you all.
Great.